Hey, what's up guys? Welcome back to the channel. Got a really cool video for you that's once again going to be very baseline tutorial, but my future videos will 100% build off this and we can do so many things with just a simple workflow. I completely automated collecting and vectorizing blog content. If you're like me, you love consuming as much information as you can get your hands on for all your favorite things. Whether it's blogs, YouTube videos, they can all pile up so quickly. I usually save or screenshot cool blogs or news articles that I want to read later, but I never end up getting around to them and they usually get lost in my phone screenshots. But this simple automation can totally take all that out and help me store all those in a vector database that I can go and query later. In this quick tutorial, we're going to learn about RSS feeds, how they work, some HTTP requests, and Supabase vector store databases. By the end of this video, you will be an expert in RSS, HTTP, and Supabase. And if you don't know what any of that is,
I don't even know what that means.
No one knows what it means, but it's provocative.
No, it's not. It's
Gets
gross.
the people going.
hold on, I'll break it down step by step. So getting into the automation here, first node here is going to be an RSS node. This RSS feed node is used to fetch and process updates from any RSS feed that you can have. These RSS feed nodes are a complete game changer whenever you want to periodically check a specified feed URL and retrieve new articles or updates as they're published. For example, this automation will be targeting a blog feed, and if you have any blogs that have RSS feeds built into them, this will be a no-brainer to add to collect those blogs and store them to your database. Now, I do want to note that the RSS feed node must use a valid RSS or Atom feed URL. It can't just be any URL that you slap in there and it works. This RSS feed node needs a URL specifically for RSS feeds. That's because they're typically structured in XML data that contains articles, timestamps, and other metadata associated with it. Regular web pages are usually HTML, won't work unless they provide an embedded RSS feed within them. So if you're able to open the RSS feed URL in your browser and it's displaying XML content, you know that it will work in this case. But I'll get into that a whole lot more as we walk through this step by step. This is just kind of a broad overview of what we're going to build so we know where we're going. And then once we get into step by step, you'll know how we're going. So then from the RSS feed, it goes into the last 24 hours. This is a quick filter node that will refine the RSS feed data output into only the blogs that were created and posted in the last 24 hours. Now, this next node, HTTP request node, this is due to the RSS feed only giving the blog links and a short little content trailer of what's in the blog. So this HTTP request node goes into those individual URLs provided from the RSS feed from the last 24 hours to get the full content of what the entire blog is saying. This last set node is set title in Markdown. It gets rid of a lot of the unneeded data that I don't need at the moment, and I can easily go in here and tweak and turn things into the specific data that I do need to go into my database. So this just makes it a whole lot easier and a whole lot more simple to go into the database so I don't have a bunch of random data all over the place. Now, for the big reveal, we're using Supabase vector store for this. And if those three words scare you to death, don't worry, we'll break it down in this tutorial and it'll be super simple by the end of it. But just to go into vector databases a little bit, just to gloss over, so we're not completely in the dark here, it's a way to store vector embeddings. And if that doesn't make sense, that's totally okay. But it's a way to store and represent chunks of data such as text, images, numerical values. It's a way to capture really diverse data and put it into numerical values that make sense to a computer to read it and to make those nuanced variables consumable by computers. So it's multi-dimensional and you'll have a long list of numerical vectors that is attempting to capture what the thing is that you are describing in your data. So for instance, king, man, woman, queen will all be assigned different variables that have some sort of relation to them in the numbers in the vector embeddings. That whenever you're talking about a woman, you can also be talking about a queen. And whenever you're talking about a king, you can also be talking about a man. And this is the same for anything that you can put in a vector database that is given a numeric vector. So you may ask, why are you using a vector database to begin with? Why can't you use a normal database? Well, these vector databases really in simple terms can give a lot of meaning to a lot of the nuances within different data sets. For example, this says queen, which could be royalty or it could be the singer queen. Those are nuances within this data set that could play a vital role in determining outcomes. So these vector databases play a vital role in AI applications that use LLMs, chatbots, or for our case, a RAG database. So this will make it 20 times easier for us to be able to query this database using LLMs or a chatbot or anything that we need to do, whether you're trying to write a blog based on the database that you have, or you're just trying to query questions about it to write an email. So now that we got Supabase vector store definition out of the way, this should make a little bit more sense as we go through. This embeddings OpenAI is the embedding model that will be giving our vectors an assigned number. And then lastly, this recursive character text splitter just breaks our data down a little bit into chunks so that it's easily storable for our database. Since it is kind of a long form blog and research that I'm going to be putting in here, I went ahead and chunk this data up to have a better experience with the data. So let's get into building this. So we have a blank N8N workflow here, and I'm just going to start it off with an easy click trigger to get us started. And we're going to jump right into the RSS feed node. So you could use an RSS feed trigger instead of the click, or an RSS read trigger, but just know that the actual RSS read node can give you a lot more data on the output, rather the RSS trigger really just tells you whenever there's a new update to whatever RSS feed that you're using. So in order to have more autonomy and ability with the data that we're getting, we're going to use the RSS read node, and we are just going to paste our URL in here. So like I said, it has to be a URL that is specifically for RSS feeds. So here, and we can go ahead and test this step. So you see here we got 10 outputs, and we have publishing date, link, and we have a bunch of data here. So now from this step on is pretty much just going to be getting more data, transforming the data, and making it consumable by our database so that we can store it correctly. So next will be the filter node. So in order for us to get the recent blogs within the last 24 hours, we have to set a parameter, an expression in here to make sure that we are getting the desired result. So we can get the current publishing date right here. And we have to set this to the date time is after. And we don't want a static date in here. So we have to have an expression in there to tell N8N that it needs to be after a moving date or whatever yesterday was. So in order to do this, we are going to have to get a little creative, and we will need an expression in here. And for those of you that don't know or don't care what I'm doing here, that is totally fine. And you can totally just copy me. And if anybody has a better way of doing this, I'm sure there is. This is just what I decided to do to get the result that I wanted. Okay, so for those of you who just copied, or for those of you that want to know what I did, all I did was I got the current date, not now, and then I calculated how many milliseconds there were in a day, and I subtracted it from the current day. So I basically subtracted 24 hours from the current day and formatted. So that is the result of that code. Like I said, you can totally just copy that. So we can test this step, and you see that we kept 8 items and we discarded 2. So these 2 items should be from yesterday. So that is correct. The next that we're doing is an HTTP request node, and I'm going to be using Firecrawl for this. So if you've never used Firecrawl, I 100% recommend. Firecrawl is an amazing open source API service that transforms websites, such as the one we're doing here, into clean, LLM ready, markdown, or structured data. It basically just helps you scrape. So here's their documentation on what we're currently doing right now with the curl. And I highly recommend that you either get acquainted with this or copy this, whether you're using ChatGPT or Claude to help you with using these tools. Make sure they understand this documentation as well. One thing that I've done that's helped me tremendously is make a Claude project for my N8N workflows, and I will 100% go in and copy all of this documentation down, or any documentation for that instance that I think is important for the LLM to know, and I input it into the project, and it makes things a whole lot easier whenever I'm trying to work through a problem. A lot of this I did use for this project. So there's a lot of stuff you can do with Firecrawl. Single URL, you can crawl, you can map, and extract a lot of the website's data using LLMs and extract only the key data that you really want, which is super cool. I'm sure I'll make a video about it in the future. If you'd like to see that, let me know. But for now, we're going to use a single URL. I basically copy and pasted one of the URLs that we got, and I input it directly into Firecrawl. You can run it, and it will give you what you will receive if you run this code. You can also go in and exclude tags, include tags, and really play around with it in here before you get within N8N. And I do recommend doing that. A lot of the data that you will scrape or get from blog sites will have a long list of stuff that you don't want. So for instance, it will have a ton of this extra data that you don't want to be necessarily in your database. So playing around with these exclude, include tags will kind of help you structure what your output will be. And I did have to do a lot of that for getting this data to output correctly. So once you put that in, you can git code, and it will give you your API key up here, but it'll also give you the C curl that you can input directly into N8N. And we will copy that, and we can paste it into import, paste that in here, and it will auto-populate a lot of the fields. I want to hop over to the code portion of our HTTP request. Now, remember me talking about the include tags, exclude tags. They will go directly in here. So you see how this current code script looks as of now. We have the URL and formats. We just want the markdown. Whenever you go into Firecrawl and you add, let's say, footer, and you run that and you get the code, you see this curl will have exclude tags footer, and that will be true for every tag that you choose to exclude within that specific URL. So the reason why I go into that is because a lot of the extra stuff that we didn't need outside of the content of the blog, to get rid of that and make this data as clean as possible, I only wanted the title and I only wanted the content of the blog. So there's a bunch of exclude tags and include tags within here. Now, for us, so remember we put in this static URL to run our Firecrawl to get the curl. We need to now make it to where we can run multiple URLs through here. So we will get the link in here and paste in here, json.link, and it will show the result over here to show that it's going correctly. And you see our test is done, and we got the markdown without all the extra BS in there. And you see that we still have a lot of this Twitter data, fave icon, Twitter card, and all this extra stuff that I really don't want in my database. I don't think I'll get very much use out of it. To make it even more consumable data, I will do a set node, and I will pass through only the things that I actually want going into my database. So these set nodes are great whenever you're working with large data sets or kind of funky data. So we can do markdown, and then we will just want the title, and we can put title in here. We can test the step, and we see we have the markdown again, and no extra data, just the title. Perfect. So now this is ready to go into our vector database. So now what we'll need here is our Supabase vector store. And we're going to add documents to the vector store. Now, I have my Supabase account already created, my credentials already in here. If you don't, I have a video linking to how to do that, and it's all very simple. So hop over to that video, watch it real quick, I'll link it up top, and come back here whenever you're done. So we will want to insert documents and from list. Now, this list will not auto-populate if you do not have a database and project set up correctly. Now to do that, you'll need to go to Docs, and this will get you to the N8N documentation of how a Supabase vector store works. Once again, this is super useful documentation that I, for one, have completely copied and pasted and uploaded to my Claude tool to help me with some of the documentation. But for this, let's go to quick start for setting up a vector database. Now this will bring you to the Supabase documentation, which is also very useful, but makes it pretty much 1000% easier to set all this up. So to initialize your database, you'll need to go to the SQL version of this, or the SQL code snippet of this, copy this, and jump over to your Supabase. So now you're in Supabase, and you want to go to your SQL editor. And you want to paste this in here to your SQL editor, and you can't see it on my screen, but on the bottom right of your screen, it will say run, or you can do Control Enter, and it will run that. And whenever you hop back over to your database, you will see, you go just straight into database and go to Schema Visualizer, you will see this documents database that was made. And you can go into tables, and you see you have now a documents table. And in your table editor, you will have a blank documents table as well. This is exactly what you needed to do to set up your vector store database in order for it to work seamlessly with N8N. Now back to N8N, you will hit this drop down and you will see your documents right here. And you can add properties and match underscore documents. Yeah, so that didn't run because we have to set everything else up first. So to do that, you will need to set up your data loader. I'm just going to do the default data loader, keep all that the same. Now what you could do in here, if you wanted to, you could load specific data. For us, I've already set the data that I'm going to be passing to it a little bit stricter, and it's a little bit easier in my mind to do it that way. And then you will want a text splitter. And the reason I'm choosing to do a text splitter, like I mentioned before, these are going to be research papers and blogs being passed to this. So they're pretty dense papers with a lot of text and a lot of volume to them. So I'm going to want them to be split up into my database. So I'm going to set this at 2000 chunk size, and I'm going to overlap by 200. And that's the chunk size is basically just how you're breaking it up in tokens, and then the chunk overlap is just how much those individual chunk sizes will overlap. So in our case, if it's the sentence is ending in I would like to see that, the next chunk will start with to see that, and so on and so forth in kind of a more dramatic fashion. And then next we need our last embedding model. So this will actually give it the number that it will be stored in the vector database for future models or future instances for us to pull from this database correctly. So I'm going to use the OpenAI embeddings model and just text embedding 3 small, keeping all that the same. Okay, so now we should be able to test this step. And you'll see that it's getting all the data and it's going kind of back and forth here. So it will chunk it and split the data, and the embeddings node will give it an embedding number. Now, at this point, remember that the Supabase table, documents table, was completely empty. We should, after this, go back and see that it is full with our data. Okay, that's run. And we are in our documents table, and perfect. This is all the data that we just passed on into our vector database. So you see our embedding vector. This is the number that I was talking about in the beginning of the video that identifies it. It's kind of an identifier for any of the models to understand what it's talking about or what the data even is that it's looking at. That will help give it some nuance and be able to read what we're passing to it. So perfect, guys. I hope you really like this tutorial. Like I said, it was very basic, very broad, but once again, I'm going to be making more videos on top of this to be able to use this data in cool ways, to be able to build on top of this simple workflow and implement more things with just RSS feeds, HTTP requests, and Supabase vector stores. So if you got anything out of this, like, subscribe, leave something in the comments for something that you want to see in the future. So until then, see ya.